For ages, humanity has gazed upward at the stars, questioning what exists beyond our cosmic neighborhood and asking if we are truly solitary in the universe. While telescopes offered us distant glimpses, they were insufficient. We needed to go there. So, we constructed machines brave enough to depart our home and venture into the unknown. Two of them stand distinct among the rest: Voyager 1 and Voyager 2. After drifting through the void for more than 4 decades, one of these legendary explorers fell silent for months. When Voyager 2 finally reconnected with home, it wasn't merely a routine technical check-in. It was a transmission from a region no human-made object was ever designed to reach. Tonight, we're going to investigate where Voyager 2 actually is, what it sensed after turning its attention back toward Earth, and why its data is compelling scientists to reimagine what lies beyond the edge of our solar system. Voyager 2 was never meant to be speaking to us today. Approved in the early 1970s and originally designated as the Mariner Jupiter-Saturn mission, it was engineered for an operational life measured in years, not decades. Yet, over 40 years later, here it is, functioning far beyond NASA's wildest expectations. Launching in August 1977, Voyager 2 utilized a rare planetary alignment, treating gravity like a cosmic slingshot to tour the giant planets. This solitary probe provided our first intimate looks at Jupiter, Saturn, Uranus, and Neptune, unveiling storms larger than our own planet, active volcanoes on distant moons, and planetary systems far more intricate than we ever imagined. But the true shock came later, when the mission quietly evolved from planetary exploration into something much more profound. Voyager 2 didn't halt at the solar system's edge. It pressed on. There are no road signs in space announcing that you are now leaving the solar system. Instead, there is an invisible barrier known as the Heliosphere, a massive bubble formed by particles streaming outward from the sun. For decades, Voyager 2 cruised inside this protective shell, guarded against the harsher environment outside. Then, in November 2018, the situation shifted. The probe recorded a sudden, dramatic collapse in solar wind particles paired with a sharp spike in high-energy cosmic rays arriving from outside our system. Simultaneously, it detected a stronger interstellar magnetic field pushing inward. These signals confirmed one thing: Voyager 2 had crossed into interstellar space. This was not a void of empty darkness. It was a violent realm saturated with radiation, charged particles, and forces strong enough to remind us just how delicate our solar bubble truly is. Communicating with Voyager 2 is comparable to listening for a whisper across a galactic ocean. Its transmitter power is weaker than a refrigerator light bulb, and by the time that signal touches Earth, it is almost inconceivably faint. Yet, following 7 months of radio silence, caused not by a probe failure, but by maintenance on Earth's deep space antennas, Voyager 2 answered. It confirmed it was alive, had processed new commands, and was still operational in interstellar space. That moment was significant. It proved that a machine built on 1970s technology, running on tape recorders and computers thousands of times less powerful than a modern smartphone, could endure one of the most hostile environments we have ever measured. More importantly, it confirmed Voyager 2 was still beaming back real data from beyond the sun's reach. Data regarding a region we cannot visit ourselves. What Voyager 2 has revealed is unsettling in its simplicity. Outside the heliosphere, cosmic radiation is intense, far more potent than anything we experience inside the solar system. The sun's protective bubble screens every planet, spacecraft, and living thing here from a ceaseless storm of energetic particles originating from the galaxy itself. Measurements from Voyager 2 confirm that interstellar space is neither calm nor empty. It is active, aggressive, and unforgiving. The implications are enormous. It suggests that long-term human travel beyond the solar system will encounter dangers we are only just beginning to comprehend. It also serves as a reminder of how rare and fragile our cosmic shelter is. Voyager 2 has evolved beyond being an explorer. It is now a warning beacon, quietly broadcasting the reality of what waits beyond the edge of our sun's protection. One of the most unnerving aspects of the Voyager 2 saga isn't where it is located, but how it is still functioning at all. The onboard computers were architected in the 1970s, possessing less memory than a single modern image file, and processing speeds so limited that today's phones outperform them by a factor of thousands. Yet, these machines operate flawlessly in the interstellar void. Data is still being written to magnetic tape, a format so archaic that no physical backups exist on Earth anymore. Somehow, after decades of radiation exposure, extreme freezing temperatures, and total isolation, the system holds together. This prompts an uncomfortable realization. Voyager 2 is not just a probe mapping space. It is proof that even primitive human technology can withstand environments we once assumed were instantly lethal. If something built that long ago can survive out there, interstellar space might be harsher than we thought, yet not uninhabitable for machines, and perhaps not entirely out of reach for humanity. Voyager 2 carries a cargo no other spacecraft does. A golden record etched with sounds, images, music, and greetings from Earth, crafted for a single purpose: to be found. This isn't scientific gear. It is a message in a bottle cast into a cosmic ocean. As Voyager 2 travels deeper into interstellar space, that record grows more symbolic with every passing year. Communication won't last forever. Instruments are being powered down one by one to save energy, and eventually, the radio signal will fade entirely. When that moment comes, Voyager 2 won't stop moving. It will continue silently, ferrying Earth's voice into regions of the galaxy we will never see. The warning here is subtle, yet powerful. Once contact is severed, Voyager 2 becomes a permanent artifact of human existence, drifting among the stars without guidance, without updates, and without witnesses. The data from Voyager 2 has exposed something we rarely consider while living under our calm blue sky. The heliosphere isn't just a boundary, it's a shield. Inside, radiation levels are survivable. Outside, the galaxy shows its true face. Immediately after crossing this invisible wall, Voyager 2 recorded a sharp surge in galactic cosmic rays alongside a stronger magnetic field pressing inward. This indicates that our solar system is encased in a fragile bubble that constantly holds back a torrent of energetic particles capable of destroying electronics, DNA, and biological systems. The warning isn't dramatic, but it is profound. Leaving the solar system isn't merely about distance. It is about survival in an environment that actively works against anything unprotected. The power of Voyager 2's discoveries lies in the fact that they aren't just about today. They concern every future mission that dares to venture further. The probe is charting a region humanity has never touched, measuring conditions we must eventually face if interstellar travel is ever to be more than a dream. Its data is already reshaping how scientists approach spacecraft shielding, long-duration missions, and the absolute limits of human exploration. Voyager 2 didn't turn back physically, but its signal did. And what it sent us was not comfort, but clarity. The universe beyond our sun's influence is real, active, and unforgiving. Any civilization wishing to step into it must be prepared. At this stage, the simple act of communicating with Voyager 2 has become a scientific feat in its own right. The probe transmits with power comparable to a small household light bulb. By the time that signal reaches Earth, it is weaker than anything we encounter in daily technology. NASA's Deep Space Network must link some of the planet's largest radio antennas just to snare that whisper from a void. What makes this even more remarkable is the sheer distance. Voyager 2 is so far away that every command takes hours to arrive, and every response is already history by the time we catch it. This delay compels engineers to think differently, forcing them to anticipate problems long before they happen. In a sense, Voyager 2 is teaching humanity how to communicate across truly interstellar distances, revealing how fragile and precious a single bit of information becomes once you leave the comfort of the solar system. The data Voyager 2 continues to stream, paints a vivid picture of the dangers lurking beyond the heliosphere. Galactic cosmic rays aren't a minor fluctuation. They are a relentless bombardment of high-energy particles capable of piercing shielding and disrupting electronics. Inside the solar system, the sun acts as a guardian, deflecting and weakening much of this radiation. Outside, that protection vanishes. Voyager 2's instruments demonstrate that interstellar space is not merely cold and dark. It is actively hostile. This holds serious implications for any future attempt to send humans beyond our solar neighborhood. The warning is subtle but unavoidable. Technology alone is insufficient. Survival beyond the heliosphere will require a fundamental rethink of how we protect both machines and living beings from a universe that is indifferent to our readiness. As instruments are slowly powered down to conserve energy, Voyager 2 is transitioning into something new. It is no longer just a scientific probe. It is becoming a time capsule. Every subsystem that shuts down marks the end of an era. Yet, the spacecraft itself presses forward, unchanged in purpose but altered in capability. Long after contact is lost, Voyager 2 will still exist, drifting silently between stars, carrying a snapshot of humanity from the late 20th century. Its hardware, its golden record, and even its outdated technology will one day represent a fossil of our civilization. This raises a quiet but profound thought. Voyager may second outlive every structure we have built on Earth, becoming one of the longest-lasting artifacts humanity will ever create. Eventually, the moment will arrive when Voyager 2 can no longer reply. Its power will dip too low, its transmitter will fall silent, and Earth will hear nothing but static. But silence does not mean the mission ends. It simply means the conversation does. Voyager 2 will continue on its trajectory, passing near distant stars tens of thousands of years from now, long after current civilizations are gone. This forces us to confront a strange concept. We often view exploration as something that ends when communication is lost. In reality, Voyager 2's journey will continue long after we stop paying attention. The warning isn't just about space, it is about time. Our reach can extend far beyond our lifespan, and what we send out into the universe may persist long after we are no longer here to explain it. When people say Voyager 2 turned back, they aren't describing a physical reversal in space, but something far more symbolic and unsettling. What turned back was its attention, its signal, its data flow toward Earth after months of silence. For a probe that has been steadily moving away from us since 1977, that renewed communication felt like a voice returning from beyond a frontier we barely understand. The signal carried confirmation that Voyager 2 was still alive, still oriented correctly, and still able to listen and respond even after crossing into interstellar space. That moment reframed the mission. Voyager 2 was no longer just moving forward into the unknown. It was now actively reporting from it, sending back measurements that directly challenge our assumptions about what lies beyond the sun's reach. One of the most critical realizations from Voyager 2's data is just how wrong our intuition about interstellar space really is. We tend to visualize it as a vast, silent vacuum, but the instruments tell a different story. Voyager 2 detected a dense environment of energetic particles, strong magnetic fields, and constant radiation pressure. This is not a passive backdrop. It is an active medium that shapes anything traveling through it. In a way, the probe revealed that the heliosphere is like a calm harbor, while interstellar space is the open ocean beyond, filled with invisible storms. This realization alone is enough to unsettle scientists because it means every object, natural or artificial, is being continuously sculpted by forces we rarely consider when looking up at the night sky. What makes Voyager 2's discoveries even more potent is that they didn't happen in isolation. Voyager 1 crossed into interstellar space years earlier and reported similar changes, though with slightly different details. Voyager 2 confirmed those findings from a different trajectory, at a different angle, and with a different set of instruments. Together, The two probes removed any lingering doubt. The boundary of our solar system is real, and what lies beyond it is measurably harsher. The spike in galactic cosmic rays and the shift in magnetic field strength are not anomalies or glitches. They are consistent features of interstellar space. When two independent messengers tell the same story from different paths, the warning becomes impossible to ignore. The most important thing to grasp is that Voyager 2's message isn't a warning in the cinematic sense. There is no imminent danger approaching Earth. Instead, this is a long-term warning aimed at the future of exploration itself. Voyager 2 is telling us that leaving the solar system isn't just a matter of building faster rockets or smarter computers. It is about facing an environment fundamentally different from anything humanity has ever operated in. Radiation, magnetic forces, and particle storms will define the rules. Any future mission, whether robotic or human, will have to be designed with these realities in mind. Voyager 2 isn't closing the door on interstellar travel. It is quietly pointing out how heavy that door really is. One of the quiet but deeply unsettling implications of Voyager 2's data is what it reveals about human vulnerability. Inside the Heliosphere, life and technology exist under a kind of cosmic umbrella, shielded from the worst radiation the galaxy can throw at us. Outside that boundary, Voyager 2 shows there is no such mercy. High-energy particles move freely. Magnetic turbulence is constant, and shielding that works near Earth becomes far less effective. This forces scientists to confront a difficult truth. Any future spacecraft carrying humans beyond the solar system will need protection far beyond what we currently understand. Voyager 2 is exposing the limits of our assumptions, reminding us that the universe beyond our sun is not designed with human survival in mind. Another insight emerging from Voyager 2's measurements is that interstellar space actively reshapes anything moving through it. Radiation doesn't simply pass through objects, it alters them over time. Electronics degrade, materials weaken, and surfaces are slowly modified by constant particle impacts. Voyager 2 itself is a living example of this process, its continued operation almost defiant given the conditions it endures. Scientists now believe that interstellar space is less like an empty highway and more like a grinding current, slowly wearing down everything that enters it. This changes how we think about long-term exploration. The challenge is not just reaching distant stars, but surviving the journey through the space between them. Voyager 2's discoveries also force us to think in terms of time, not urgency. The data it sends today will shape missions that may not launch for decades or even centuries. Its measurements are not warnings for the present, but instructions for the future. They tell future engineers where shielding must improve, where instruments must adapt, and where our understanding is still dangerously incomplete. In that sense, Voyager 2 is communicating not just with today's scientists, but with generations yet to come. It is a reminder that some messages are not meant to provoke fear, but patience and preparation. As Voyager 2 continues its journey outward, its role becomes almost philosophical. It is a small, fragile machine carrying the weight of human curiosity into a place where curiosity alone is not enough. Every transmission is weaker than the last. Every response is harder to detect, yet each one carries immense value. Voyager 2 is showing us that the universe does not announce its dangers loudly. It whispers them slowly through data points and long-term trends, through a probe drifting alone in the dark. And those whispers, if we choose to listen, may determine how far humanity can truly go. When you assemble all the pieces, Voyager 2 stops being just a spacecraft and becomes something else entirely. It becomes a messenger, not from another civilization, not from a distant star, but from the edge of our own protection. What it sent back was not a single shocking image or a dramatic signal, but a slow, undeniable truth built from years of data. Beyond the heliosphere, the universe is not empty, not calm, and not forgiving. It is filled with radiation, magnetic turbulence, and energetic particles that relentlessly shape everything that enters that space. Voyager 2 did not turn back physically, but its signal did. And what it carried was a warning about limits. The limit of our technology, the limit of our protection, and the limit of how casually we speak about becoming an interstellar species. This probe, built with computers weaker than a smartphone and powered by fading nuclear batteries, has survived longer and traveled farther than anyone imagined. Yet, even it is slowly being worn down by the environment it revealed to us. That contrast matters. It tells us that exploration beyond our solar system is possible, but it is not simple, not safe, and not something we can rush into without understanding the cost. Think about it this way. For all of human history, we have lived inside a bubble we didn't even know existed. Voyager 2 was the first to step outside and describe what it feels like out there. And what it found forces us to grow up as a spacefaring civilization. The stars are reachable, but the space between them demands respect. Voyager 2 is still out there, drifting farther away, its signal growing weaker, its journey continuing long after we stop listening. And that may be its final lesson. The universe does not warn us loudly. It gives us time, data, and one chance to learn. If you want to keep following this story and others like it, make sure you're subscribed because the most important discoveries often happen far from the spotlight. Share your thoughts in the comments because this question affects the future of exploration itself. And remember, every time we look toward the stars, Voyager 2 is already there, quietly reminding us how vast, powerful, and unforgiving the universe truly is. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.